Okay, so major and minor arcs and sectors. So this is really straightforward. It's just pretty much the same as what we've just done, but using the words major and minor. So let's say we have a circle, okay? And let's say this circle has a part of the circle that's not that, but more something like this and like that, okay? So O, A, and B, some measured angle, and R and R. Then the minor sector is the smaller of the inside of the circle, like this. Which means that the minor arc is the outside. So that's the minor arc, okay? So pretty straightforward. Now the major arc, of course, is just the opposite. So the major sector is that part there, and the major arc is that one there. Now, if you ever have a straight line as your sector, then there is no major and minor, of course, because essentially it's the same. So, like, whatever you do, it's going to be the same both sides. So we don't really identify too much about that. But anyway, minor, little, major, bigger. That's it. That's pretty much it. Okay, example. Let's get it done and over with really quickly. So find the area of the perimeter of a major sector if the minor sector subtends an angle of 120 degrees and a radius of 20 meters. So let's say we have a circle. Radius is spelled wrong, how annoying. So we have a circle like this, okay? And so you might notice it from the previous video that this part here is equal to 120 degrees with a radius of 20. Now what we did before is we actually calculated the minor segment of this circle. And we also did the sector too. So we did the arc length here on the outside and the inside of that one too. What we're essentially wanting to do in this one is we're wanting to do the opposite. And we're going to use some of the tricks for this one to do the opposite as well. So that being the outside is 240 degrees. So we know that the angle of a complete circle is 2 pi. So that is equal to 360 degrees. And from the previous example, we worked out 120 degrees was 2 pi on 3. So equals 2 pi on 3. So we can work out what the leftover, or the 240 degrees is, by doing 2 pi minus 2 pi on 3. Okay, which is the same as 6 pi on 3 minus 2 pi on 3. So it should mean that we get 4 pi on 3 as our 240 degrees, or doubling 120 is 4 pi on 3. Okay, so that's what our angle is going to be for this one, okay, over here. So pretty straightforward, I think. So 4 pi on 3. Now we want to start off by finding the perimeter. So remember, the perimeter is the outside of the major, so it's going to be along here, and along this bit here, okay? So we need to find the arc length for the outside. So L is equal to, and we remember it's equal to R times the theta, which theta is our angle. Now the radius in this one is equal to 20, and our theta, or our angle, is 4 pi on 3 for this one. So 20 times 4 pi is 80 pi on 3, and that's our arc length. So our perimeter becomes 80 pi plus 20, or 80 pi on 3, sorry, plus 20 plus 20, like before, okay, which is the same as 80 pi on 3 plus 40, which is the same as 80 pi plus 120 on 3. And that's the total perimeter. Now the area for this one is exactly the same way as we did before. So it's a half r squared theta. So it's a half times 4 pi on 3. So we'll start with the angle first, because the fractions are easier to multiply, and then multiply it by 20, squared again. So 4 pi on 6 times 400, which is the same as 800 pi on 3. And that's in meters squared, and that one is in meters, I believe. Yes, it is. Okay, so there we go. That's it. So pretty straightforward, very simple stuff. And that's it for this video. Just looking at the major and the minor sectors, I believe. I'll just double check quickly before I sign off. maybe not. Oh, no. Okay, there's another example about major and minor sectors. I'm just trying to have a look. Oh, and we've got area of a segment, which we will look at shortly as well. Okay. So, find the length of minor... So we'll do this one. Okay, so part A says find the length of the minor and major arcs formed by two radii of a circle of radius 10 meters meeting at 45 degrees. Okay, so part A is a circle like this, and we've got it. So it's like, I want that one to be actually be a bit better. So it's something like this. It's 45 degrees here, and it's 10 meters and 10 meters. Okay, so what we're going to do is we're going to find the length of the minor and major arcs. So we're going to find L1 and L2. So L1, so first we're going to find our value there, so 45 degrees. So converting that into radians, so times it by pi on 180, and that's going to give us a quarter pi. So 45 degrees is equal to pi on 4. So length 1 is equal to theta r, which is pi on 4 times 10. So that's 10 pi on 4, or 5 pi on 2. Now our second length, okay, that one there, so it's going to be 2 pi, so our theta value, so theta is equal to, so it's 360 minus 45 degrees, or in other words, 2 pi minus pi on 4, which is the same as 8 pi on 4 minus pi on 4, which is then the same as 7 pi on 4. So that's what our angle is. So L2 in that case is going to be equal to theta r, or r theta, whichever way you want, which is 7 pi on 4 times 10. So that angle is then, or that length is 70 pi on 4, or 35 pi on 2. So there's our two lengths there. Now part B says find the areas of the minor and major segments. So part B is pretty straightforward too. So segment, it's EN, segment 1 is equal to, so it's a half theta r squared. So in this case, it's going to be a half times, and this will be for the smaller one. So segment 1 is the small. So it's pi on 4 times 100. So it's pi on 8 times 100, which is equal to 100 pi on 8. Like that. So segment 2. Okay, also half of theta r squared. So in this one, it's a half times our theta value for the second one, which is 7 pi on 4 times 10 squared. So it's going to be 7 pi on 8 times 100, or 700 pi on 8, or something smaller, 350 on 4. I don't know if that gets any smaller. Probably 175 on 2, yeah. So 175 on 2. And that's our unit. So that's units squared, whatever the unit is. I think it was meters. Units. Units. Yeah, meters. There you go. Okay, find the area of triangle AOB, where O is the center of the circle and A and B are the intersection of the radii of the circumference of the circle. So basically it's saying that if this was connected, and actually a proper circle, so it went like that, then we want to connect these two like this, okay? So A and B, and we want to find the area of this triangle here. Okay, so if we're wanting to find the area of that triangle there, we're going to have to think back to some trig rules. The area of a non-right angled triangle. So part C, the area of a non-right angled triangle, A is equal to half AB sine C. Now sine C in this case is 45 degrees, or pi on 4. 5 pi on 2, sorry. No, that's not right. Pi on 4, yes. So C is equal to pi on 4, A is equal to 10, B is equal to 10. So substitute those in, we're going to get a half times 10 times 10 times sine of pi on 4. So A is equal to, so 100, so it's 50 sine pi on 4. Okay, and we know that sine pi on 4, so thinking back to your exact values, or just, thinking back to your exact values. So when is sine equal to pi on 4? We can put this into our calculator too if it's in radians mode. So sine of pi on 4, okay, equals to root 2 on 2. Okay, so if you don't have one of these calculators, I won't do that for you, obviously, but sine pi on 4 to 45 degrees. 45 degrees is root 2 on 2, or 1 on root 2, it should be. So 50 times root 2 on 2, which is equal to 25 root 2. So that's the area, and that's units squared there. So that's what it's saying is that triangle part here is equal to 25 root 2 squared. And remember, we've also got this arc length here. So the total arc length, including the little bit up here, equal to 100 pi on 8. So that's the area of triangle AOB, where O is center and AB are the intersection of the radii and the circumference of the circle. Okay. Now for the major and minor segment. Now the segment for this part, okay, so let's remove this coloring in. It's beautiful coloring in, if I don't say so myself. Whoop. So the segments now are these bits here of the circle where the two lines cut it off. So this is the major circle, the minor segment, and it also says for the major segment. Now the major segment is just the minor segment plus the So the major segment is this part here. The minor segment's this part here, but the major segment is all of this part here plus this triangle here. So it's the rest of the triangle, essentially. The rest of the circle, essentially. So all that part there is the major. So blue is major segment. Okay, so it's essentially splitting it in half. And the green is the minor segment. Okay. So we've already calculated all the parts for the blue and all the green. So it's just a matter of doing a little bit of trickery. So part D. So for the minor segment, we'll start with the minor segment first. So minor segment is just equal to the minor segment, so the whole part, the minor sector, minus the triangle. So minus triangle AOB. Okay. So the minor sector we worked out in part B, which was, these should say sectors, not segments, because it's very different. Sectors, my bad. So sector 1, sector 2. So sector 1 was equal to 100 pi 8. So 100 pi on 8 minus AOB, triangle AOB, which was just above, which was 25 root 2. And there's no tricks to do this one. It's just literally plug it straight into your calculator and hope, for everyone's sake, that it is a positive number. Because if it's not positive, it means we've done something wrong, but I don't think we've done anything wrong. So 3.91 units squared. Now the major segment is a little bit different. It's the major sector plus triangle AOB. Because if you think about it, or if you see, it's essentially the sector itself. So it's this part of the circle, the major sector, plus this triangle here, which gives us the whole of that part there. So major sector in this case, it's 175 pi on 2. I'm going to be adding the triangle AOB, which is 25 root 2. And that should be equal to 175 on pi plus, or over 2, plus 25 root 2, which is equal to 310.24. Now, just to double check to make sure that that is correct, the major segment and the minor segment should add up to the full area of the circle. So the full area of the circle is pi times 10 squared, which is 100 pi. So essentially, the minor segment, so it should be, let me do it like this, so it should be 100 pi on 8 minus 25 root, oh, that's not what I want, root 22 plus 175 pi onto plus 25 root 2. So this should be equal to 100 on pi, and yes it is. So just to double check, these two added plus together should give area of the whole circle. And there we go. So that's the last little bit of the trig that we're going to be looking at, besides one last lesson, which will be on some trig graphs. Okay, then we will have the advanced trig stuff finished for year 11. So with that being said, we're going to leave that there. That's going to be the end of this video. It's going to be the end of this little series, and I'll talk to you guys in the next one.